I might set some things up for you online to maybe look at and go through on your own at your own pace if you want. It's entirely up to you. I can help you with that. All right, kiddos. So guys, yesterday we were on this whole idea of finding total mass using integrals today, and what we want to start looking at today is, all right, we're going to start kind of locating centers of mass. What's up, Ryan?
Parson, can I borrow your chessboard?
Yep.
All right, thank you.
Yeah, just leave the check on the desk, okay? Are all the pieces there, kiddo?
Yeah, yep, all the pieces are here.
Perfect. Okay, so guys, we talked about this whole idea yesterday that we could use definite integrals to find total mass if I knew a density and had a density function in maybe a certain volume or a certain area. And today what we want to start looking at is for some of these objects that have mass, we want to kind of find out where the center of mass is. And we kind of best describe the center of mass yesterday as a, remember, kind of like a balancing point, okay? And one type of mass that we're going to start talking about here, guys, today is this. It's called a point mass, okay? So in this case right here, we're going to talk about where the center of mass is, but they talk about it as a point mass. So we're saying like at one specific point, this is how much mass is there. So it's you know, not difficult to do. I'll show you a formula. We'll make a visual representation of what's going on here, and then I think that when you see this, you'll be like, oh, that's it? Like, yep, that's pretty much it. So let's talk here. Guys, it says find the center of masses of a system containing 3 point masses of 5 grams, 3 grams, and what else? 1 gram. And they're located respectively at what values? X equal negative 10, x equal, and x equal. Okay, so here's what I'm going to do. Let's make a little line here. Let's make a line segment first. Okay. So I'm just going to do this. So okay. And here's the deal. What are the x values that we're talking about here, kids? What's one x value? What's another x value?
1.
So we're at x equal 1. And what's the other value? 2. Okay, so let's just pretend this. It says all of these masses are located respectively at the following. So it means the 5 grams would fall on what x value, kids? Okay, so right here at negative 10, there are 5 grams sitting here. Okay. How many grams are there at 1?
3.
And then how many grams at x equal 2? Isn't there 1 there? Now guys, one would think that, okay, this is where all the mass is. So it's somewhere between negative 10 and what?
2.
Okay. The center of mass has got to be between here somewhere, right? Does that make sense to you? You might want to maybe guess where the center of mass would be to balance that given those masses at those points.
Middle, left 2 for 1.
Okay, so left of 1. Okay. Well, let's check it out. Okay, anytime you're dealing with point, you know, I like to call it center of mass based on points. And I'd really like to do this, I'd like to call it center of mass for, I'm going to call it endpoints here. Okay, now there's a formula for this. It states the following. It says the center of mass for points will equal the summation of all of your x values times your masses all over the summation of, I believe, all of your total masses. And you're like, what the heck does that mean, right, Parson? And you're like, yep, what the heck does that mean? Okay, all this is saying, guys, is this. This is simply saying take all of your x values times all of your masses and add them all up, okay? So right down below here, let's talk about this. Guys, if I took this mass times a particular x value right here, this would be your first x value times your first mass. So what's this product going to be right here? Negative 50. Okay. What's this product going to be right here for 3 grams at x equal 1? Isn't that 3? What's that last product going to be between location of a mass? 2. Okay. This top line is simply saying take each product right here and add them up. So this means the center of mass right here is going to equal. Okay, what are the 3 values we got here?
If you add them all together, it'll be negative 45.
Okay, yep, if you add them, you're ahead of me. So I'm going to write them as negative 50 plus, what did we say, 3 plus 2? Now, this is over all the sums of just the what, kids? M of I just means that you've got, I don't know how many of them, okay? In this case, we have 3 of them, so you're going to add all the masses. That's what this really means, okay? What's first mass? What's second? And what's last? Okay, the x value for your center of mass is found by computing the top and dividing it by the sum of all the masses there, okay? What'd you say the top was again there, Grant?
Negative 45.
And then what's the bottom going to add up to, kids? Okay, how about this then, kids? What's negative 45 over 9? What kind of 5? Okay, does it make sense that the center of mass would be between negative 10 and 2? And probably closer to negative 10 because most of the mass is over there, right? So, here's the deal. This here is equal to what value again? Okay, so if you have points right here, the way you find the center of mass amongst points with certain masses at certain points, this is how you do it. Okay, so the center of mass, I would write, and I'm going to change colors on it, might be right, oh, let's get fancy here today. This looks good to me. Maybe negative 5 right there. Okay, that would be the balancing point of all that stuff right there, at negative 5, okay? So that wasn't too difficult, was it? Okay, point masses are pretty simple. Point masses are pretty simple. You just take the products of the mass times each respective point. Everywhere you have that, add them up, and then divide by your total amount of mass. Okay? Now here's what I want you to think about, guys. We took some x values times a mass here, didn't we? And we divided by a total what? Okay, I want you to keep that in mind, okay? X times the mass over the what? Total. Okay, so that idea is going to come back up here in the next problem, okay? Because we're going to start looking at finding center of mass, not with points, but using what here? We're going to start finding it using what? Okay, now you guys see this little symbol right here. If you want to change this little gamma function to f of x down there, you can do that, okay? Guys, what this is really saying is the following. The center of mass, x bar of an object lying along an x-axis between A and B is given by the following. Center of mass is equal to the, this is kind of like x times a function again over just the function. Isn't that like x times the mass over the mass again right there? Okay, this part down here on the bottom, the integral of your function when you're given densities like this here is going to be your total mass down here. And this is going to be the product of x times each mass right up here. Okay? So it says where this is really f of x is the density of mass per what? Unit of length of the object. So let's talk about what's really going on here, guys. It says find the center of mass of a rod that's how many meters long? 2 meters long, lying on the x-axis with its left end at what? Okay, so I'm going to sketch this real quickly. I'm going to make another line segment here. We've got this rod that's laying on the x-axis. Okay, I know the left end over here is what value, kids? Okay, and I know the right end will be what value over here? Okay, 0 and 2. Now, here's the deal. It says find the center of mass of a 2-meter rod lying on the x-axis with its left end at the origin if, part A, the density is constant and the total mass is 5 kilograms. The density everywhere is exactly the same, okay? So one would think if the density is consistent or constant throughout this whole rod, where might the center of mass be for this? Right in the middle at 1. Okay, let's show how they prove this. Okay, guys, we've talked about this right here. We know that the mass of an object would equal a density times either a volume or an area, right? Or in this case, it would be density times probably a length, wouldn't it? Okay, so what we look at here, guys, is this. We start looking at little slices right here. So I'm going to say, okay, let's just pretend right here this is a certain length, delta x. Okay. Now you guys have told me that the mass will equal the density times a volume. In this case, it'll be a density times a certain. Notice right here, the density over here is going to be kilograms per what? Meter. Okay. So it's going to be the density times a certain length. Okay. So guys, the mass of my one slice right here, that's going to equal my density. Do we know the density? We just know it's what? Constant. And the total mass is what? 5. Okay. All right. Ew, I don't like this question. All right. Well, here's the deal. We would know the mass is well, we already know the total mass, don't we? Okay. So I don't really even need to go with a total slice here, but the mass has got to equal 5, doesn't it? And doesn't the length of this little slice just have to be delta x? So this would be the density, whatever the density is, times delta x. So the density would be 5 divided by oh, take that back, take that back. I've got a problem here. Okay, hold on. I've got a problem. Don't let me do that to you yet. Get rid of that. Okay. We would know the mass is equal to the density times the what, kids? Okay, here's what I want to point out. What was the mass again? 5. Okay, that's for the whole rod, right? That's going to equal your density times your length. What's the length of the rod? 2. Okay, so the density has to equal 5 over what? You okay with that? Okay, the density is going to be 5 over 2. Now guys, to prove or find out where the center of mass is in this right here, we need to look at the mass of one slice. And the mass of one slice again is a density times what? Okay, well what is the density here again? 5 over 2. What's the length of one of these slices? Okay. Be delta x, right? So the total mass, ooh, that's a bad looking T. Total mass has got to equal the integral from what to what? 0 to 2 of 5 over 2 times, this will become what? Dx, right? Well, we know the total mass there, right? Okay. The total mass right here, guys, this part right down here, this part right here is always going to be your total mass in this right here. Okay. So the total mass function is the integral of 5 over 2 dx, right? Okay. Which means then this, to find the center of mass, we have to use the formula. We're going to take the total mass function, f of x, times what? Okay, so that would be the points, what all the points are. So here's what we end up with here for center of mass. We'll move up here. Okay, I'm gonna say then the following. The center of mass by formula will equal the integral of, what are my limits on this? 0 to 2 of x times our function, which is what here, kids?
5/2.
All over the integral from 0 to 2 of 5/2 dx. Okay, so let's check this. Again, we know that the density is constant here, so we think the center of mass is probably where? Right in the middle, at what value? Okay, let's see what happens here. Let's do this top integral right here. So let me jump in decimals. Oh, come on, Parson. Okay, what's the top part say there, kids? Want the integral from, was it 0 to 2?
Yeah.
Of x times
5/2 dx.
Okay, what do we get in the bottom? Or the top, I mean? 5. Okay, so that top value is 5. The bottom is going to be the integral from 0 to 2, right? Of what?
5/2.
Wow, it's going to turn out to be what over what, kids?
5/5.
Which puts us at what value?
1.
And isn't that kind of what we expected there?
Is by golly.
Okay, this becomes 5/5, right? Whoops, 5/5, you get there, right? I don't know what's going on with this. So the center of mass occurs at what value?
Not 1.
Okay, now that's part A. That's just part A. Part B is a little more difficult. Part B says the density is not a constant anymore. The density is what? Okay, think about this. The density on the far left. If I threw 0 in for x squared, what's 15 times 0 squared?
0.
It's like saying there is no mass over here at this point. Okay? No mass at this point. Weightless at this point. I shouldn't say weightless, just no mass at that point. Okay? Plug 2 in for x. What do you get? At this particular value, it weighs 60 kilograms. So as x increases, what's happening to the density of this bar? So where is most of the mass contained, the right side or the left side? So one would think that the center of mass would be closer to the heavier side than it would be the side with nothing over there, right? So I think this should be closer to 2 than it is to what here? Okay, let's talk about this, all right? I'm gonna make some room up here. Okay, I'm gonna do part B now with this. So over here we have 0. Over here we have 2. Okay, we need to find the mass of one slice here first, kids, to get total mass. We gotta come up with a function for total mass. Okay, that total mass is the bottom, and we'll put some more words up here. So here we go. Do you guys agree that this is a delta x right here? Okay. You guys agree that the mass of that little slice, just in here, the mass of that little slice right there, has to equal my density function for that particular x value times the length of that right there? Would you guys all agree with that? Okay. Well, help me with this then, friends. The mass of this slice is going to equal, what's the density function at that particular x value, kids?
15x squared.
It's going to be 15x squared times the length of this little slice, which is what, kids? So the total mass then, I'll write m total down here, that's going to equal the integral from What are my limits on this rod? Of 15x squared dx. Okay. Now, guys, we've talked about how do you find total mass. If you know how to find total mass with a function, then you know how to find the center of mass with the function. Because it simply becomes this function times what up top? Okay, so my center of mass moving forward on this one, in part B, I'm just going to put an x bar here. X bar means center of mass. What x value is that balancing point? That's going to equal the integral from 0 to 2 of my total mass function times what? There you go. All over the total mass function. Okay, so let's get these values figured out. Is that okay with you guys? You guys agree the top one's really 15x cubed then? Because x times 15x squared would be 15x cubed, wouldn't it? Okay, so we're 0 to 2, but we're x times, what was it, 15x squared in here this time? Okay, so the top is what value? Okay, and then the bottom, can I control copy this and paste it? Does that let me do that? Well, good gravy it does. What am I going to get rid of for the denominator, kids? It's going to be 60 over what, kids? 60 over 40. So let's go ahead and execute that. Yeah, and is that closer to 2 than it is to 0? And it makes sense because as I move further right, what happens to the density values? Yeah, the heavier part is over there. Okay, it's kind of like this is almost like a baseball bat if you think about it. The heavy part is way at the very end of the barrel. Okay, so let's take a look. This became 60 over what? So what x value would be the balancing point for this? So if the density along this rod was defined as 15x squared from 0 to 2, meaning whatever the x value is at a particular point, that tells you the density there in kilograms per meter. Then to get this to balance, that would balance at what x value there. Okay, so here's what I really kind of want to go back up to with this. Now again, guys, this is not relative on points. This is relative on the whole rod right here. This is kind of like saying it's the integral from a to b of x times your total mass. And I'm just going to put integral here of x times your total mass over the integral of just your what here, kids? That's what that formula really says there when we're dealing with something like that. Now, do you understand the difference when I say this x value, and this x value have a certain mass at 3 different points compared to the masses at all points? Okay? And maybe I should write this down. This function works for the center of mass not just at particular points, but this works at all points right there. So maybe we'll add that little note in there. Okay? What do you guys think? Kind of okay with that formula for finding center of mass?
Yeah.
Well, let's pretend we're not dealing with just a rod anymore. Let's pretend we're dealing with something completely different. Like maybe we have a shape that's positioned on the x-axis. So we got to figure out in there. Oh my gosh. Is there one more example on the next page? Oh, I bet there is.
In a triangle, dude.
Oh my gosh. It says the following. Okay, so we have a triangle right here where it says, looks like it's actually, yeah, it's isosceles, isn't it?
It says it up there.
Does it? That's,
Yeah.
ah! Find the coordinates of the center of mass of the isosceles triangle. The triangle has constant density and mass what? Okay, so it's got a mass of m, a constant density. Okay, guys, we're talking about a triangle that's kind of Does it look like the x-axis? Well, if this is isosceles, it looks like the axis is gonna go ahead and be an axis of symmetry, doesn't it?
Isn't the isosceles like one is two the same size?
Two sides are equal, so this side right here, I'll put a little tick mark maybe there. I wish I could write with this pen, that would be cool.
Let's get on the no sides.
But you've got a little tick mark maybe here and here. Okay. Well, my friends, here's the deal. Okay? If we're assuming constant density throughout the whole thing, it means like, if I say the density of this is like 6 kilograms per square unit, that just means that the density is the same at every point. But now, guys, where's more of the area confined at? Further left or further right? Okay, so if I had to say this, you know, I think it's going to be along this x-axis somewhere because it's somewhere in the middle here all the time. You know, like if I would draw a line straight out here and straight out here, wouldn't I be right in the middle of that constant? But more of the weight's probably where? To the left or to the right? So do we expect our center of mass to be closer to 0 over here or closer to 1? Closer to 0, because more of the mass there. Okay, so here's the deal, kids. We've got let's use this idea here. Okay, let's use this idea. So we've got the center of mass is equal to the integral of our x times the total mass. Can I write Tm, is that okay for total mass? Over the integral of just the what? Okay. So here's the deal. We're used to finding total mass after I can find the mass of one slice, right? Would you agree with that? Okay, so this is going to kind of go back into our 8.1 stuff. What I'm going to do is this, kids. I'm going to slice my triangle up this way. I'm going to say, you know what? Let's find the area of this slice right here. I don't like that. Where'd my tools go, kids? There they are. Let's do it this way. I'm going to sit down over here and do this. Okay, maybe here's a slice right here. Now guys, if I look at this slice as it is here, do you guys agree that right down here this would be a delta x, a change in x for the width? Okay, so what shape am I really forming there, kids? It's really going to be a rectangle, isn't it? Because that width is going to be so small, right? So you guys agree that this is going to be a width, which is a rectangle? Okay, so I'm going to call this right in here delta x. Okay. Now guys, you go back to your days of 8.1 when we were rotating stuff, but just talk about this. If this is the x-axis, isn't this vertical right here a certain distance y going up to this point right here? Isn't this a certain distance y right here? Going down to this? So really the height of this rectangle is how much? 2y, and then the width is really going to be delta x. Right? Okay. So let's talk about this right here. We know that density has to equal, in this case, mass over a what? Okay. And we're talking about two-dimensional shapes, so it would really be mass over area, wouldn't it? Okay. All right. Don't know what the density is. It's a constant. So let's talk. You guys agree the area of this slice would be 2y times delta x? Which means we better get that all in terms of x then, if we're using delta x as our width for that slice, right? So let's talk about this right here. Guys, could we come up with an equation for this line right here? Okay. What's the slope going to be? It looks like down half and over how much? Okay. So So isn't this gonna be y equals negative 1/2 x plus how much? Okay. Okay. Let's see if we can't come up with the mass of a slice right here. Okay, we know the mass of a slice would have to equal our density times our what? So our density. Is it okay if I just call my density, say a constant d? Is that okay, kids? You guys all right with that? Okay. Times the area. Okay, the area of this right here, what's the height?
2y.
2y. Times delta x, right? Okay. Now the density d is a constant number. It's some number. I don't know what it is, but it's some number. Okay. And maybe we'll pick a number to put in there. Better get y in terms of what here, kids? Okay, watch this right here. I'm gonna cheat. Is that okay?
Yeah.
All right. I know y is equal to what? Okay. What if I doubled this up here? If I doubled this, wouldn't these double also? So wouldn't I know that 2y, which is this part right here, 2y would equal double of this, wouldn't it?
Yeah.
Or I could take all this right here and double it to get that, couldn't I?
Yes.
Okay, so help me double all this. What's negative 1/2 x doubled? Isn't that negative x? Plus what? Okay, so the mass of one slice is really going to equal some constant d times, what do we say, negative x plus 1? Okay? And then, so what's that make the total mass then, kids?
It was pretty good. We did I did the she's broke at the end and broke the time. Yeah, broke well the plunger like the rubber piece came flying off.
From what limits?
Oh, hit someone in the ball.
Okay, some constant d, I'm gonna put that constant d out front, is that okay? Times negative x plus 1 dx, right? You guys okay with that? All right, once I've got the total mass figured out here then, can't we go ahead and work to find center of mass here? So check this out, I don't care what the density is. What I do care then is this, how do you find the center of mass? Well, the center of mass, my friends, will equal the following. It's going to equal, okay, some constant d up top times the integral of, what do I have to put up top here, times this function? And what are the limits on the top one? Okay, and then the bottom is going to be some constant d times the integral from 0 to 1 of just negative x plus 1. Okay, so let's see what happens here, guys. You guys got that written down? Everybody have that right there? Okay, let me go and get the top here. Now keep in mind that constant that's out front is some constant density, right? So right here, help me with the integral part. What are the limits again, 0 to 1? Okay, and then we have x times what?
Negative x plus 1.
Okay, do you guys agree that that's 0.16 repeating, so that's really 1/6. Is that okay with you guys? I can go up here and put this into a fraction like 6, so you guys agree 1/6 right there?
Yes.
Okay, so up top here, my friends, what we end up with is, I'll just write it here, the top is equal to, okay, the definite integral part was 1/6 times what constant still out front here, kids? Okay, let's do the bottom integral. So I can just get rid of the x, right? What do you get down there?
What is going on?
I'm not really sure. Get 1/2 there, don't we? So the bottom will really be that definite integral is 1/2. But guys, what constant's still out front here? We're constant what?
D.
Okay, what are the d's going to do to each other in our final answer now? They're going to cancel, aren't they? So guys, we're left with 1/6 over 1/2 for our center of mass, but that would mean instead of dividing by 1/2, couldn't we multiply by the reciprocal, which is what? This is equal to 2 over 6, so where does that imply the center of mass is going to be? What x value? Okay, now is 1/3 closer to 0 than it is to 1? Did we expect that to happen? Okay. All right, guys. So this whole idea today about center of mass is x times the total mass function, that definite integral, over the definite integral of just the total mass, and that's going to help you find your centers of mass, okay? All right. Questions for me at all?